Hey, welcome to the Config Bench. This is John, and today we're going to do a quick review of Labs 1 and 2. Where in Labs 1 and 2, we looked at DC series circuits, and here is an example of Lab 1. We had a voltage power source. It should be a 9-volt battery. It ranges, because it's an old battery, anywhere from 6.87 volts, up to 9 volts. And it was a single resistor. And what we were doing is we were showing that we were going through an amp meter. And today that amp meter will be reflected over here with this digital voltmeter, the red one, and that will be our amp meter today. You can see the connectivity, positive is in the volt ohms and milliamps, and the negative is in the DC amps. And then the Sperry is going to be, checking our DC voltages, and that is this guy here. And if we use the values that are here, we are going to see that the simulation calculates that we're going to get roughly 146.17 milliamps with the 6.87 volts in. And the breadboard, we've got a couple different breadboards. This breadboard, so here we are with this breadboard. We have the single resistor that is here. We've got positive power coming in. We have the negative side of the power that's going to be coming in. And then we got the blue leads are the test leads that are going across the resistor. It's a 47 ohm resistor. These are jumper wires extending the positive power over to the resistor. And then the negative here, and it's just like here. We have the positive coming up, going through the amp meter, and coming to the positive side of the resistor, and then the negative side going back to the negative side of the battery, and the digital voltmeter is going to go across and measure that. So that's what this circuit is all about. The second circuit that we are going to look at is where we added a resistor, and this is called a resistor that is in series. And this breadboard, same idea. We got power coming in, both positive and negative. Power is being extended over to the resistor, the first resistor here in series with the second resistor. Both of these resistors again are at 47 ohms. And the blue connectors here are just our test points. And our second resistor over here, and going back to ground. So that, and if we calculate the values here, so it's the same thing, positive going through the amp meter, first resistor connected to the second resistor, going to ground, and we are going to be taking measurements off of across the two, and then we're also going to be taking measurements, at the midpoint. And again, here it's 8.5 volts. Depending on what battery you're using will determine what you get. But for this, we're going to do a DC calculation. And we see that it's 8.5 volts up here with 90.425 milliamps for the circuit. And 8.5 volts up here. Midpoint, it's about 4.25 volts. And then, of course, ground down here. So that is our second circuit that we are just kind of following up on in our last lab. And then what's new today is the parallel circuit. So we have the original circuit, starting with the battery, going through the amp meter, going through two resistors. But what we're doing is we're adding two resistors, and they are in parallel with these two. So these are in series, and these are in parallel. This set is in parallel with this set, and then we're going to be making voltage readings across, up here, and then we'll also make it at the midpoint. And if we do a simulation, 8.4 volts and all this, we go calculate, we can see that now we're down to 17.872 milliamps. We changed the value of the resistors to 470 ohms because we were drawing a little bit too much current with the 47 ohm resistors. Anyway, so that's what we're about to take and display with the breadboards. And this is this circuit. So you can see two sets of resistors. We got the first set down here, they're in series with each other, but then parallel to that we have the second set of resistors that's up here. And it's the same idea. We got power coming in, we got a positive and a negative coming in. That is being extended over to the resistors with this jumper. The ground is being extended over with this jumper down here. The blues represent us just finding different test points in between. But then this resistors up here, which represent these here, we're extending from this plane down here to this upper plane up here. And, you know, again, these two are in series with each other, but these two are in parallel with these two here. And so we're about to hook power up to these, and we'll go from there. Okay, so here we are. We've got the single resistor breadboard set up. We've got the positive power about to go in here. We got the negative, coming out here. Positives being extended over across the resistor. We got our test points. We've also added an oscilloscope here, so we can do DC readings on the oscilloscope, and we'll get more into what that's all about. I'm about to connect the power, and we are going to see our DC voltage reading. So we have 6.5 approximately volts going across the circuit. We're estimating at 6.87. I'll change that slightly. And we're going down, but we have 135 milliamps. One thing to note, it's very important to understand what circuit you're about to hook up, because with the amp meter, if you connect and you estimate incorrectly how much current you're going to put through it, you can easily blow a fuse. Let me get my paperwork. You can blow a fuse very easily. So here, I was estimating we're going to have about 150 milliamps, going across here, and so I've chosen the 200 milliamp range for the amp meter, and then I estimated we were going to be less than 20 volts, for the voltmeter, and we are at 20 volts, and here we are. We can see our voltage readings here on both the meters. So here we are with our second circuit, and if we look up on the screen here, Lab3, we have two resistors in series. They're both 47 ohm resistors. We've got reading going across. We've got the voltages dropping. This battery's getting worn out, but it's down to 6.87 volts. We're down to 75 milliamps. Over here, and if we look at the oscilloscope, where it says that we're at 7.02 volts, and we're going to talk about discrepancies. So 6.8 volts is a reading across this digital voltmeter. Here we got an oscilloscope that says it's really 7.02 volts DC, and we are going to change this voltage uh, 6.82. So I'm going to hit enter there. We got 6.82, and now when I do my simulation, I'm going to calculate the bias, and it says, hey, with 6.82 as far as the simulator is concerned, we should have 72.5 milliamps. And if we look over here, we're 74.9. And so we're actually 6.8 volts right now. So let's, yep, we're pretty darn close to, you know, but things are off a bit. And we talked about tolerances for the resistors. So there could be a 5% tolerance variation for each one of these resistors. These meters, and the reason why I'm saying this, here's your config bench, okay? Here's an oscilloscope that, you know, you might spend anywhere from $20 to maybe $40 for. Breadboard, you know, $3 or $4, you know, the components. And then your digital voltmeters. I mean, I went on Tamu. This is a $7 digital voltmeter. So you're not going to get precise accuracy. The tolerances of the components that are in these, they are also probably at about anywhere from 2 to 4%, you know, tolerance values. You know, so the readings that we're getting here that simulate, this is going exactly by Ohm's law. Calculate this. And any differences that you're seeing, don't get stuck on the differences. Just recognize that this equipment, even though it's not precise enough that you'd be calibrating your most precise equipment with, it's getting you in the game, and it's showing you that, you know, we can measure these different points and see the value of current, we can see the value of voltage, and don't get hung up that they're a 0.5 or whatever volt or amp. Okay, so here we are now with the third circuit. The resistors are now in parallel. If we look, we've got two sets of series resistors. We've changed the ohms from 47 ohms to 470 ohms just so we can draw less current. You notice that the voltage has increased from 6.8 or 6.5, wherever it was. Now it's up to 7.9. And that's because we've increased the resistance, which reduces the current. And this battery, it's starting to become an old battery, so it's not given the full 9 volts and the full current capability that it could. So anyway, we're at 7.92 volts. I'll change this value here. And it is 7.9. There it is, 7.9. And with 7.9 volts, if we simulate the bias, it is going to show that we should have 16.8 milliamps with 7.9 volts. We got 7.93 and we have 17.1 milliamps. So pretty accurate. And if we look at our oscilloscope here, it is showing that we've got 8.1 volts, so slight difference. And again, back to our tolerances, that's okay. And then I want to show you with the with this circuit, what we're now going to do is measure the voltage instead of from here to here, which is currently 7.9. This is the voltmeter going across. That's my Sperry. We're now going to, you know, tap off of the center here. And so from 7.9, I suspect we're going to have anywhere from 3.9 to 4 volts, you know, at this midpoint. And so we've disconnected. You can see the current is still going at 17.1 because we haven't interrupted that. And now when we connect here, I'm right at 4.02 volts, right at the midpoint here. So it's a voltage divider, and that kind of concludes today's introduction to parallel circuits. So 3 circuits, 3 breadboards, 2 meters, a pocket oscilloscope, a 9-volt battery. This whole setup is under $60, you know, so hopefully, you know, you can get started and know that you don't have to buy top-end gear to get started in learning electronics. Lab 1, it was a single resistor, you know, we showed maximum current going through it. Lab 2, it was series set of resistors, voltage divider, and there was, you know, seeing the current had dropped, we increased the resistance so current would drop. Lab 3 was a parallel voltage divider. We split the current through two different paths, as you can see here. Current's coming down 16.8, half of it goes down this and half of it goes down this. We also showed that there was a voltage divider, so we changed the meter of the positive probe. We ended up going here. We saw that we had 4 volts. That's where we are right now. 17.1 milliamps. And here, you know, the math said it was 16.8. Again, we're about 0.3 milliamps off, which is nothing, you know, so don't get hung up that we have different readings. Our oscilloscope is showing that it's 8.15 volts going across from here to here. Right now the voltage, if you can see it, and I'm going to focus in on it, that the voltage, let's try to get focused in here, is on the oscilloscope. I'm going to disconnect the voltage, and I'm going to connect the voltage. I'm going to disconnect the voltage. You see that the line, it's a straight line, because the oscilloscope is a graphical representation of voltage. And right now, that yellow line that you can see here, the settings are 2 volts per scale. So it's going to go 2, 4, 6, 8. And then it's going to be slightly above, right around there. And so when we connect this, you're seeing that it goes right up to where we'd expect, and also the measurements on the screen just show that it's 8 roughly 2, and it's varying slightly. So we've seen, in the next video we're going to go into Ohm's law in detail so that you can see why is it these certain voltages and resistance values and current values, how do they all calculate with a set of formulas called Ohm's law. And Ohm's law is kind of the foundation of learning electronics. You need to understand Ohm's law. Ohm's law is what we use to calculate, you know, if we have the 9-volt battery and we have certain resistors in line, whether they're in series or parallel, how do we calculate all that? And the next video is going to go into that in great detail. And speaking of the next video, we'll be announcing the winner of this oscilloscope very soon. So you're looking at the oscilloscope that I'm willing to give away. All you have to do is answer a few questions that'll be in the next video. If you answer those questions correctly and you explain how you got to those answers, and you also, subscribe to my channel, then you would be eligible to win this oscilloscope. So anyway, thank you for joining the TheConfigBench. Again, this is John, and looking forward to creating the next video with you guys. Thank you. Bye-bye.